the process in the ARP4761, and an ARP stands for Aerospace Recommended Practice, by the way, in case you were wondering. It thinks about things in the standard engineering V life cycle. Are you familiar with that?
Yeah.
Okay. And from a safety perspective, it sort of splits that into three broad parts. So it's like this. So we have the functional hazard analysis, the preliminary system safety assessment, and the system safety assessment. Have I already gone through this with you?
Yeah.
Right, okay, yeah, okay, that's fine. So when you do the FHA analysis, it's a bit like, it's basically a list of functions, and then you do some functional failure.
This is a FHA.
FHA, yeah, functional failure. And then out of that analysis, so you've got some functions, you think about the functional failure modes, and out of there you have failure condition outcome from that. And that failure condition will have some kind of severity level associated with it. Now in civil air transport we have 4 levels. We have catastrophic, hazardous, major and minor, and each of those has a set of safety criteria, objectives related to it, and they depend on the severity of the outcome. So for catastrophic failure condition, you're not allowed any single point failures that will lead to it, which is a standard thing. But also they then put numerical probabilities on these as well, quantitative. So you'll have like 10 to the minus 9 for catastrophic, 10 to the minus 7 for hazardous, 10 to the minus 5 for major, and then 10 to the minus 3 for minor. And these are per flight hour. And it's, you know, it's that per flight hour thing is basically from the time that you get on board the aircraft to go flying and the time you shut the aircraft down. So they talk about a flight phase. The other thing as well is obviously over and above all of this, you'll be thinking about your flight phases. So when I say flight phases, clearly we're talking about an aircraft. You know, if you're talking about a ship, it'll be ship phases, you know, sailing phases or whatever you might call it. But that will define, you know, like, let's say you have a loss of the engine, functional failure, loss of propulsion. If you're on the ground, it's probably not going to be that severe. But if it happens in flight, it could be very severe. But of course, you design your aircraft to have multiple propulsion systems so that you're not reliant on one. You know, it goes back to this single point failure criteria. So the output of all of this are these things called failure conditions. And those failure conditions have some safety objectives applied to it. And you basically take those together and they then form the tops of your fault tree analysis. So this is where you do your fault tree analysis. Now a fault tree analysis is essentially a top event. So you have your top event which relates to each of the failure conditions. And so if the failure condition is, let's say we've numbered failure condition 1 and it's a catastrophic failure condition, we know that this top event needs to be in excess of 1 to the minus 9 per flight hour. So we know starting whatever contributes to this top event, it needs to achieve 1 to the minus 9 from a numerical perspective. We also need to know that it's got no single point failures. So the fault tree is basically constructed of logical AND gates or OR gates, depending on what the structure is. Let's say it's an AND gate at the top and some OR gates, for example, like so. And then underneath that you have a series of what's called base events, like this. And those base events in this fault tree, you can see these two base events over here, A and B, C and D. So this top event can occur if A or B and C or D occurs. And if the top level probability needs to be less than 10 to the minus 9, then the probabilities of these base events needs to be quite stringent, if that makes sense.
Okay.
Does that make sense where we are at the moment?
Yes.
Okay, cool. Now separately, you do an Fmea, and that Fmea is broadly similar to the FHA. You can either do a functional Fmea or a component Fmea. You probably do both of these depending.
Okay.
Component Fmea is a very popular version that's used all over the place, especially in healthcare now. They're going crazy with Fmea. But you essentially look at the component, you look at the failure modes for each of those. So if I do a table like this, like that. The same again for this, you'll have some effects. You might decide to think, well, are they critical or not, however you define that. So I think, what else might you think about? You might think about the failure rate. So for that particular failure mode.
Okay.
And you might also classify the severity in terms of local effects or system level effects. And it's all about different levels of abstraction. You know, this is where it gets a bit complicated because you can be all over the place. So that's sort of a very high level failure modes effects criticality analysis. And so each row in this will be, so let's say we've got one component. Let's say this is the component here. The component might have multiple failure modes, and those failure effects might be, there's multiple failure effects. If you want to think about the criticality, you can. I'd probably suggest not, because that's making it too complex at the moment. You'll have some type of failure rates associated with that. And then you might also consider the severity on the system or the local effects. Like if you have a water pipe, a hydraulic pipe burst, not only do you lose the function that the hydraulic fluid was performing, but the effects of having a hydraulic pipe burst might be that you have hydraulic fluid sprayed around inside the aircraft, for example. So you can look at both of those. Now, when I was talking about failure modes and effects summaries, essentially what you'll find is some of these failure modes, they might have similar effects, and so you would group them like this, if that makes sense. And so to join these two together, so joining fault trees and event trees together, in fact, yeah, there we go. Sorry, joining fault trees and FMEAs together. Some of these base events down here might be related to certain component failures, and so they can be directly related to some of those. Or it might be that they're a group of failure effects, and you might group them like that. And you'll notice that these are the effects, but clearly you've got failure rates associated with it. So this is where you get your failure rate numbers from that would then feed into the fault tree analysis. So you can do both a qualitative analysis and a quantitative analysis, both with the same tools. But of course, the level of certainty you have about quantitative numbers is a bit of a challenge. Because if you imagine that you did a functional analysis and you identified some software failure modes, behaviors, you wouldn't be able to fit them in this fault tree with probabilities because there aren't any. So instead of having a fault tree, you would do the same activity, but you'd refer to it as an error tree. Same logic, same structure, same approach, just without numbers. And this approach, this analysis approach, fault tree analysis, allows you to set requirements, for things like independence. So if you imagine this is a catastrophic failure condition here, this AND gate suddenly becomes really important. And so if this base event over here was related in some shape or form with the base event over here, clearly that would violate the AND gate. So you can start looking at what's called common mode analysis. Situations where a failure or set of failures come about because
are fault tree and Fmea made at the same time, or
not necessarily, because you can do from this point here, you can do a set of high-level functional fault tree analysis to help set requirements and targets. But until you get down this side of the V life cycle and start to come up this side, you won't necessarily know what components you're going to be using. And it's only when you've decided what components you're going to be using, you can really do a proper FMEA. So it's during this sort of switchover period that you start to create your FMEA, your component FMEA, and then you use that information to update your fault tree analysis during the SSA phase. Does that make sense?
Yeah. Yes.
Okay. I mean, it's quite a complex topic and process to talk about to somebody new, because you have to introduce this one page contains about 50 concepts. And if you're not familiar with any of them or most of them, it can be very time consuming to learn about. And it does take a while to sort of get your head around. But there are four distinct analyses here. There's the FHA, the FTA, and then the FMEA. But the FMEA can be done in two parts, functional or component. Now, I've not seen it, it's very rare to do both functional and component FMEAs because it is an expensive, time-consuming activity. Because if you imagine, go on.
No, I was thinking, but why should we do both FTA and FMEA?
So a fault tree analysis is a what's called top-down analysis approach. So you start at the very high-level system perspective, and then you analyze down in different layers all the way down to components and to specific component failure modes if that's necessary. Whereas an FMEA starts from the component level and goes bottom up, so it's called.
Okay.
So you're sort of taking, if you imagine that this is the FTA approach, system component level, going this way, an FMEA is basically going the other way, like that. And at some point they'll meet, in theory, and that's what this link is here. That's where they meet.
Okay.
So you do really need to do both of those, really, because you might not see something on the way down, and also on the way up you might miss something. And it's also important to note that an FMEA from this perspective, looking that way, is looking at single component failures. Whereas when you're looking downwards, you're looking at combinations of failures. That's what this is, these are combinations of failures. which you won't see looking just at components. And that's why it's frustrating seeing how healthcare have got hold of Fmea and they're loving it and trying it. They don't realise that that's just one perspective. You need two perspectives to be able to understand what the issues are.
Yeah, because actually, I think that it depends on the, I read on the Olnager book, the casualty credo.
I'm not sure I'm familiar with.
So actually, that in safety, the so-called safety one is based on a casualty model.
Yes.
But actually, when you go from down to up, because of because the system isn't linear, you can't be sure that you will find the causes.
Absolutely.
It's different when you go from the cause to the effect, but the vice versa isn't something possible because the system isn't linear.
Yes, correct. So when somebody says top down and bottom up, they're referring conceptually to two things. The first is the system abstraction, conceptual abstraction from system down to component level, but there's also a so structure abstraction, time abstraction, moving forwards and backwards in time, but also in terms of cause and effect. And that's not necessarily linear, as you've just said. So, and this is one of the challenges with learning this stuff, is because this picture, this represents three different concepts in one. But unless you are attuned to the fact there are three concepts there, or somebody's taught you in that way, it's not obvious at all. Now, the other thing to notice as well is, and I think you've already noticed this, I'm just going to be a bit facetious, is failure, faults, failure rates, numbers, failure conditions, all of this. This is a failure-focused process. It doesn't look at dangerous successes, and that's why the stamp-based approach beats all of this together. Now, I'm not saying that all of this should be thrown away, because I think it's a good, robust process. If people follow it, they'll get some good results, but it needs to be supplemented with STPA specifically, or STECA. But of course, if you're looking at the system life cycle, you would apply STECA here, and then you would apply STPA here in parallel with FHA. Because in fact, some of the results of STPA are exactly the same as FHA.
Yeah, so FHA lose sense.
Say again?
To do FHA, if you are already doing STPA, I think that it doesn't make sense.
Yeah, you wouldn't need to do it. You don't need to do it. The only thing that supplements FHA over and above STPA is the spectrum of outcomes. So STPA, you're very much focused on the worst case. So what are the losses? What are the hazards? Death and destruction. So it would only really focus on catastrophic, whereas it's important to also think about lesser severe scenarios. But that's, from an STPA perspective, it's not a difficult thing to add. Instead of just talking about catastrophic hazards and losses, you think about less severe hazards and losses. The process doesn't change. The control structure doesn't change. It's just how you classify unsafe control actions. So what I've just shown you there is something that is incredibly valuable what I've just described, because it shows not only the aerospace process, but also how STPA could be supplemented within it. I mean, you already know STPA, so I don't need to talk about, developing them, doing the hazards, doing the losses, hazards, high-level safety constraints, then building your model, then doing the analysis of the model, and then setting requirements. You already know all of that. But the thing to highlight is you can apply STPA so much earlier in the life cycle in terms of time that knowledge can help develop the concept, and even design and component selection. And then once you come to do the SSA, System Safety Assessment, you've already got a control structure. So you're just making sure that the control structure that you designed is what's been implemented. And so long as it is the same, then awesome. If it's different, you have to reiterate the analysis. That's it, really. So yeah, I don't know if that's sort of helped or whether that's just blown your brains out on a Saturday morning.
No. It's very valuable, and everything is. I think this page is so full of concepts, and so it's something that I really appreciate, especially the comparison with when you introduce STPA and STECA.
Yeah. Well, the functional failure, the failure conditions here, they are the equivalent to the STPA unsafe control actions. That's the basic same. Now the challenge then is traditionally they'd go and start doing fault trees, whereas STPA you would start defining causal scenarios by analysing your control loops. That's the only difference. But of course, fault tree analysis doesn't work for control loops. Conceptually, it doesn't work. I mean, you could try and do it, but you'd end up with a massive, really deep fault tree that has, difficult logic in it.
Yeah, the fact that all this involves lots of data and lots of work, so it's hard, I think, to fulfill all these analysis all together.
Yes.